Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at higher expansions. So what I mean is we're going to look at expanding binomials where the power here is greater than 2. So to do this, we need Pascal's triangle. This is how you draw Pascal's triangle. You start with a 1, the next row has a 1 on either side. Now, for every subsequent row, you always start with a 1, and what you do is you add the two numbers to the side to get this number in the middle. So 1 plus 1 here is 2, and the rows always end with a 1 as well. So the next row, I would start with a 1, 1 plus 2 is 3, 2 plus 1 is 3, and I end with a 1. Next row, start with a 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and they always end with a 1. Now just be careful that when you're looking at Pascal's triangle, it always starts with row 0. So this is row 1, row 2. So row 4, for example, is the one that has a 4 in its first entry. Now, why did I say first entry? Because each of these ones here, they are called the 0th entry. So this here is row 4 entry 0, row 4 entry 1, and so on. So what does this have to do with expansions? Well, this is actually really going to help us. Let's say we want to expand x plus 4 to the power of 3. I could write out x plus 4 in brackets 3 times, but that will take a while. Instead, we're going to use this shortcut. So what we do is we start with the first term to the highest power. So here it's 3. The next term is going to have an x squared. What I'm doing is taking the first term and I am decreasing its power each time. Okay, now we do the opposite for the 4. So we're going to start with 4 here to the highest power. Now we're going to go from left to right, decreasing the power by 1 each time. So notice that in each of these terms, the powers always add up to 3. So each of these is a separate term. I'm going to put a plus in between them. Now, each of these 4 terms, 1, 2, 3, 4, needs a coefficient. That's for what you use Pascal's triangle. So because it's to the power of 3, we go to row 3 in Pascal's triangle, remembering it starts at row 0, row 1, row 2, row 3. And if you've done it in the order that I've just said, you can just write in these coefficients. So the coefficients will be 1, 3, 3, 1. So let's just simplify this a bit. Of course, 4 to the power of 0 is 1. 1 times 1 is 1. I don't need to write a coefficient of 1. The first term is just x to the power of 3. The next term, 3 times 4, x squared. The next one, 3 times 4 squared is 48. X, and the final term, x to the power of 0 here is just 1. So this is just 4 to the power of 3, which is 64. I can't simplify this. There are no like terms, so I'm done. Let's try x minus 2 to the power of 3. So we've got the same idea here. We're going to start with x cubed. We're going to decrease the power of x by 1 each time. Now we're going to do the opposite for the 2. So we're going to start 2 to the power of 3 on the right-hand side, and we're going to go the other way, decreasing the power by 1 each time. Once again, for each of these 4 terms, the powers always add up to 3. Now, here we have a minus in the bracket. How does that change things? It means that every second term will be negative. So this one here is positive. The next term will be negative. The next term's positive. The next term is negative. So they switch between positive and negative. First term always positive, and then every second term negative. So once again, we'll put in the coefficients, same coefficients from row 3 of Pascal's triangle. Okay, first term is just x to the power of 3. The next term is 3 times 2, x squared. Then 3 times 2 squared gives 12x. And the last term is 2 cubed, which is 8. All right, let's do now a power of 4 expansion. So it's going to be the same idea. I'm going to start with the highest possible power of the first term. I need brackets here though, because in this term I'm raising not only the x to the power of 4, but also the 2 to the power of 4. So as I go along with each term, I decrease the power of that first thing each time. And just like in the last one, I go 1 to the power of 4, 1 to the power of 3. I'm decreasing the power each time. So notice that in this one, the powers of each term always add to 4 because it was to the power of 4. Now, because there is a negative here, the first term is going to be positive. Every second term is going to be negative. So it goes negative, positive, negative, positive. Now I need to use Pascal's triangle to input the coefficients. Because it's power of 4, I go to row 4 of Pascal's triangle. So the coefficients are 1, 4, 6, 4, 1. So just simplifying this, 2 to the power of 4 is 16. So the first one is 16x to the power of 4. Then minus, now we've got 4 times 2 cubed. So 4 times 8 gives 32 x cubed. In the next one, I have 6 times 2 squared, so that's 24. In the next one, it's 4 times 2, so that's where I get the 8. And the last one is just 1 to the power of 4, which is 1. All right, let's look now at some more challenging questions. So we're going to calculate the coefficient of x to the power of 6 in the expansion of this here. I don't really want to go through and expand out the whole thing because that will take too long. Instead, let's just find the term to which this belongs. So to get an x to the power of 6, we're going to have to take our first term, x squared, and we're going to have to cube it. Now, because the powers will always add to 7 when we expand it, as we learned in the previous slide, the other term will be 4 to the power of 4. So this is starting to look like what this term will be. Now, to understand what the coefficient will be here and whether it's positive or negative, we need the 7th row of Pascal's triangle. So if we're looking at this first term, by first term I'm talking x squared here, this will be x squared to the power of 7, to the power of 6, to the power of 5, to the power of 4, to the power of 3. It will be this one here. So we can put a 35 here. Now, will it be positive or negative? So the terms will be positive, negative, positive, negative, positive. This one here will be positive. So it's going to be this term here. That's what the term will look like. So the coefficient is simply 35 times 4 to the power of 4. You can use your calculator and you get 8,960. All right, let's look at this next question. We're going to calculate the value of a if the coefficient of x to the power of 8 in the expansion of this is equal to this large number here. So again, we're going to look at what this term would have to be. So it would have to be 3x all to the power of 8. Has to be that. That's how we get x to the power of 8. And then it'll be times a. Now the power of a must be 2 because as we learned on the first slide, whenever you have a term, the powers always add up to this number, in this case 10. So now we just need to figure out what is the coefficient here. Again, we need Pascal's triangle. In this case, we need the 10th row of Pascal's triangle. So this is what the 10th row of Pascal's triangle looks like. I didn't write all of it out because we don't need all of it. This will be x to the power of 10 term, x to the power of 9, x to the power of 8. This is the number that we want, 45. So I'll put that out the front. So because the coefficient of x to the power of 8 is this number here, all of these numbers, when we multiply them together, must equal that. So I have 45 times 3 to the power of 8 times a squared equals that number. So now I simply divide this number by 45 times 3 to the power of 8. I get a squared is equal to 4. Now just be careful here, there are actually two solutions. I can have a equals positive 2 or negative 2. And we can write it like this. This just means positive 2 or negative 2. So two possible solutions, we're done. All right, let's now look at applying what we've learned to surds. All right, let's look at how we would expand root 2 minus 1 to the power of 3. So we're going to use what we've learned on previous slides. So we're going to start off with the first term here, root 2 to the highest possible power. And with each subsequent term, we're going to decrease the power by 1. And then we're going to start with the second term, which is 1, highest possible power, and each term we are going to decrease its power by 1. Again, making sure that for each term, the sum of the powers is equal to this number here, 3. Now, because there is a minus in this bracket, we'll have the first term positive, the second one's negative, then positive, and then negative. And Pascal's triangle tells us that the coefficients will be 1, 3, 3, 1. Now we just need to simplify it. So root 2 to the power of 3. So root 2 squared is 2, times it by root 2 again, you get 2 root 2. Here again, root 2 squared is just 2, so this next term will be minus 6. Here we just have 3 root 2, and the last term is just minus 1. So simplifying this, 2 root 2 plus 3 root 2 gives us 5 root 2. Negative 6 minus 1 is negative 7, and we are done. All right, let's now look at doing this here. Root 6 plus root 10 to the power of 4. So I can use Pascal's triangle and what we've learned in previous slides. An easier way, though, when you're doing power of 4 might be that I square this and then square it again. So I'm going to calculate root 6 plus root 10 squared, and then I'm going to get my answer and square it. Because squaring is a lot easier. To square something, a binomial expansion that is, you just simply square the first, square the second, and in the middle is twice the product of those two things. So root 6 times root 10 is root 60. So I'm going to take that and square it. So just making it a bit easier on myself, this is just 16 plus 2 root 60. So now I'm going to square this. The way I do that, I square the first, I square the second. So 2 root 60 squared is 4 times 60, which is 240. And what goes in the middle is 2 times 16, 32, times 2 root 60, 64 root 60. All right, and then of course 256 plus 240 is just 496. So 496 plus 64 root 60, and we are done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.